In this section here, we're going to be talking about the derivative. And this, what I'm about to write, is known as the definition of the derivative. Okay, so I'm going to write f prime of x. So this little thing right here means prime is equal to, now you know what this is in the previous sections, we're going to be taking the limit of delta x approaching 0 of f, if I can write, f of x plus delta x minus f of x over delta x. And I'm going to give an example. Let's say, for example, we're going to start with an example before I start talking about how we come up with this right here. Okay, to find f prime of x. First, we got to find an f of x. Okay, and I'm going to define my f of x as 5x plus 2. And now I'm going to use this formula right here. So I'm going to take x plus delta x. So f of x plus delta x. And I'm going to substitute all of this into here. So this is x plus delta x and then plus 2. Alright. And of course f of x is just our function, and then we will write delta x. So let's see if I can sneak that in down here. So alright, we're just going to focus on this piece right here. Alright, so I take my, actually, you know what, I'll just go ahead and write the whole thing. F prime of x is equal to the limit of delta x approaching 0. Now, I'm going to take this whole piece, so 5 times x plus delta x plus 2 minus our f of x. Now I'm going to start a parentheses here because of this minus sign, alright? So the f of x is just f of x, or 5x plus 2. And that is all over delta x. Alright, what we'll want to do now is, I won't rewrite that, but we do always need to rewrite our limit. Delta x approaches 0. So let's clean this up here. We have 5x plus, distributing that 5 across, 5 delta x plus 2 minus 5x and then minus 2. Right, we want to distribute this negative across. And that's all over delta x. So then we write the limit as delta x approaches 0. Okay, let's see, what do we have here? We can, let's see, we can cancel those guys out because we have a positive and a negative, and we can cancel our 2's out. Alright, so I'll just go ahead and rewrite what we got. 5 delta x over delta x. So we have the limit as delta x approaches 0. Now these delta x's can cancel out, and we're just end up, all that stuff collapses down to 5. And the limit of a constant is just the constant. So the limit of 5 as delta x approaches 0 is just going to be 5. So remember, this is f prime of x. So f prime of x is equal to 5. Alright, so we come up with f prime of x equal to 5. Now, if you don't know exactly what we just did, you might be scratching your head. What exactly does this represent? Well, I'm glad you asked, because I'm about to clear that up. This right here, okay, is it's like finding the slope of the line on a curve. And let me just draw a picture and clear all this up for you. Or at least try to attempt to clear this up. Okay, so this is how my picture is going to go. I'm going to draw a y-axis, and then I'll draw an x-axis, and then let's use a different color here for our curve. So let's say that we have some graph that does this, okay? And I'm going to pick a point. We'll pick a point right here, and we're going to pick another point right here. And let's say that, for example, I wanted to draw a line, so I draw a line through that passes through both these points here, okay? So because I'm not going to be able to draw a straight line, I'm going to attempt to draw a straight line. Okay, we have a straight line here that passes through 2 points on our curve. And at this point in your math career, you should remember how to find the slope of a line. Well, if we're given 2 points, okay, then we should be able to find the slope of this line. Given 2 points on the line, we can find the slope. Remember, it's m is equal to y2 minus y1 over x2 minus x of 1, right, where x1 and y1 is a point and y2 and x2 is a point. Well, what happens if I were to fix this point right here and take this dot and start moving it? Okay, if I take the dot and then I start moving it and we draw a new line, and then I move it down, we draw another new line, and I move it down even closer, and then we draw another new line that passes through both of those points, and then I get closer and closer, and we continue to do this, and I get closer and closer and closer and closer. In other words, this dot here is approaching this dot. Well, as I get closer and closer, in other words, as I let delta x approach 0, what happens is we end up getting a new tangent line, and I'm just kind of guesstimate this is about like that right there. Ooh, that doesn't look good. But anyway, this line right here is known as the tangent line. As we get closer and closer and closer, as delta x approaches 0, this thing is approaching what's called the tangent line right here. It becomes the tangent line. But this line is known as, we have a name for this. This is the secant line. Okay? This line here is the tangent line. And to find the slope of the tangent line, we're going to need to find f prime of x, because f prime of x is going to give us the slope of this line right here. Alright, if I were to let this be x and this right here is y, in other words, the coordinates for this point is going to be x comma f of x. Right, that's going to be the coordinates. In other words, it's like x of 1, y of 1, let's say. This line, its coordinates, now we're going to go over some distance, and the distance we're going to go over is delta x. So this point, this is x plus delta x. In other words, we start at x and we go over, let's say, 10 units. So this would be x plus 10, right? Whatever x is right here, whatever this number is. Okay, so we have our x coordinate, our first coordinate, and then our second coordinate. So I guess, so this point right here, its coordinate is going to be, the first coordinate, be x plus delta x, and then f of x plus delta x. And now we have 2 points with 2 defined coordinates here. Alright, so I'll just write those out again right down here. We have x, f of x, and we have x plus delta x, and f of x plus delta x. I remember when I was first learning this x right here really threw things off. This is just all one single number right here. You got to keep in mind it's one single object, this x plus delta x right here. Okay, so we're going to use our slope formula up here, y2 minus y1 over x2 minus x of 1, to find the slope. So I'll just even label it as m is equal to, okay, so this is like our y2 here, so f of x plus delta x minus our f of x over, this would be x plus delta x minus x. Now, as you can see here, we can cancel some things out. In other words, this x minus x, those guys can be canceled out. So now we're left with f of x plus delta x minus f of x, and it's all over delta x. So that's going to be finding the slope of the secant line. That would be this guy right here. Now we're going to use the power of the limit. We want this delta x right here to get closer and closer and closer. In other words, to get smaller and smaller. We want the x plus delta x to get closer and closer and closer to x by letting this number right here go getting smaller and smaller and smaller. In other words, approaching 0. So this way our secant line becomes our tangent line. Okay, the good old tangent line has all kinds of applications out there. So now we could say now that f prime of x is equal to, we could say it's equal to m, but I'm saying that it's equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. Now let's go back to our original problem. If you remember right, the original problem was f of x is equal to 5x plus 2, and when we took the derivative of this using the limit, f prime of x was equal to 5. Now let me just sketch out this graph right here. So f of, or 5x plus 2 is going to be something that looks like this. Okay. But if you were to pick a point somewhere on this line and you wanted to know, okay, what's the tangent? What's the tangent line look like at this particular point? Well, the tangent line is this line, and the slope of this line is 5. So that's the reason that no matter what we plug in to our derivative, the slope is going to always be 5. Okay, so this may not be clear yet, but it will be eventually, because we're going to work another example on this. Okay, so we're going to find the derivative of another function this time. So we want to write down, first off, let's get this out of the way. Let's write down the derivative again. How to get it? Using the limit as delta x approaches 0 of f of x plus delta x, and I should say sometimes they use the letter h here instead of delta x, but I'm just going to use delta x. Seems like when I learned it though they used h over delta x. We know how to now to derive this right here. This is just the slope of the secant line. Alright. We're going to let our function be 3x squared, and we want to find, so we want to find f prime of x, and we're going to use the definition up here. So f prime of x is equal to the limit as delta x approaches 0. Okay, so we're going to say 3 times x plus delta x squared, right? We're taking x plus delta x and we're plugging it into the function, minus f of x, which is 3x squared, and that's all over delta x. So now what we're going to do is we're going to simplify this stuff up. Alright, so we got to always rewrite our limit. If we don't rewrite this part, you could get it wrong. Okay, so this is 3 times x plus delta x times x plus delta x minus 3x squared, and that's all over delta x limit delta x. We must rewrite this every time. So we want to multiply this stuff out. And I'm just going to leave the 3 out for right now. So x plus x is x squared. Then you'd have x plus, or x times delta x, and then delta x times x, so that's plus 2x delta x, and then delta x times delta x is delta x squared minus 3x squared. That's all over delta x. Okay, I guess we're going to end up having to write this out again. Well, no sense in skipping any steps, because that's where I normally lose people if I skip steps. So we have 3x squared plus 6x delta x plus 3 delta x squared minus 3x squared, and of course that's all over delta x. Now we can cancel things out. So the 3x squareds cancel out, right? And that looks like that's it for right now. So we have the limit delta x approaches 0. We have 6x delta x, 3x, I'll just go ahead and rewrite, plus 3x squared delta x. Now, this delta x can go into this, and delta x can go into this term here, which is going to now reduce down to 6x plus 3 delta x. Letting delta x go to 0, so this term becomes 0, and so you're left with 6x. So f prime of x, is equal to 6x. So that will be the derivative of f of x. F prime of x is equal to 6x. So let's keep that in mind. F prime of x is equal to, actually, let's just move over here to this side of the whiteboard. And I'm going to attempt to draw a graph. Well, that's terrible, but it's really hard drawing on these writing pads. If we were to graph out, our function was 3x squared. Okay, so it would look something like this. This guy would be good for finding the tangent line at any given point on this graph. Alright, so let me attempt to draw a tangent line. Here, we'll do that in red. So at this point here, for example, let's just say this was 2. Okay? And I would draw a tangent line to this point right here. Alright, this definitely doesn't have slope 2, but this thing, you have to tilt your head a little bit. Anyway, if you were to plug 2 into the function down here, f prime of 2, you would end up plugging 2 in, you would get 12, right? 6 times 2 is 12. So this would have a slope of 12, which, by looking at this picture, this does not have a slope of 12. So tilt your head a little bit there, about 30 degrees or so, to the right, and try to get that slope to be 12. But anyway, this line right here would have a slope of 12, and this is your tangent line. Okay. I think in the next section on tangent line problems, we'll be talking more about this, but you got the idea of how to find the derivative using the definition. And that's what this main section is over. I just wanted to slightly cover how to find the derivative using the definition. Okay. Now I'm going to give you a hint that there are shortcut methods that we're going to use in the future. We can't find the derivative of a function every time like this in the future. Because this is just 3x squared. What happens if this was x to the 4th power, or 5th power, or 6th power? Right? This thing would be so nasty, we'd end up spending our whole day just finding the derivative of a function. So there's a shortcut method of doing that. Maybe you should try to find the pattern. Anyway, okay, well, I'm going to leave it at that with the definition of the derivative. And check out the next section on the tangent line problem, because then we'll put a better picture to it, and I'll use actually a graphing utility to do that instead of my great drawing. Anyway, all right, thanks.